right, let's get started. Always throws me off when the music stops while it's transitioning songs, but it just happened to time up perfectly there. All right, let's do this. One more lecture. We got break coming up. We can do this. Today is an open-ended examples lecture. As always, when I do these, I say as always, but I think this is only the second time I've had one in 312 this semester. When I do these, I have a bunch of demos. Like, we don't have any strict content that we need to cover today. There's nothing we have to cover. Everything for homework 3 is out there. I've said everything I need to say about homework 3. It's all out there, and we're not starting homework 4 until after break. That's when WebSocket content will start. So I'll have homework 4 and project part 2 released over break. So today is just examples that I think will help you with homework 3. And I have examples prepared that I think will help you, but I'm not always right. Like, it's not always exactly what will help you. So if there are suggestions, if there's something that you're all struggling with, that you could use more reinforcement, maybe I didn't explain so well in lecture, that's something we can go into. You can ask for, you can hit me up in chat or whatever and say, I'd really like to see an example on this. With some exceptions. Sometimes I'll just say no, actually. If you're asking about application objective stuff, I usually do say no-ish to that. It depends on what the exact ask is, but learning objectives for sure, for various reasons. I don't know. I don't feel like going off on a tangent on that. So let's do examples. I'll just go on rails on what I think will be helpful based on the mistakes that I see in office hour questions and stuff. But I'm open to questions. Open to get sidetracked on these lectures. Otherwise, I'll just go off on rails. I probably have an hour and a half of content. I'll go off forever on my own anyway, left to my own devices. So with homework 3, I've been looking at the submissions coming in just to see, just how it's going. And most of the submissions I look at I will see an error where they're very clearly converting an image to a string, which is something I've probably said. You're probably getting sick of hearing me say an image is not a string, it's bytes, it's random bytes. But I don't know if the message is getting across because I'm still seeing the error a whole bunch. So there might be a disconnect between me saying that phrase and what the hell do I actually have to do in my code to address that. So let's talk about what the issue actually is and then talk about what we're going to do to fix it. So I have this. Let's start with I got to do the on-time lecture question again, apparently. It's not just that you come in late, it's that you're also loud doing it. You're not even paying attention when I'm saying that. If you're coming in late, at least do it quietly. Don't sit down, make a ruckus, and then talk to each other right away. It's bad enough that you're already late. All right, so I have this code that's going to copy a file. It's going to do it the usual way. I did it, slightly different. I think somebody asked one lecture, and I changed my code and just never changed it back. Not using with as, but opening it manually. So I'm opening the file. I'm opening it in read mode and in bytes. So I want to read this as binary. And then call or open the file in binary mode. Read the bytes. That's going to give me the bytes in binary. Close the file manually. If you do with as, this closes the file for you, so you never have to worry about closing the file using this syntax. And then for some reason I should just delete this. I don't know why I have that there. I think somebody asked a question, how do I get the length of the file? And I just said len, man. Just len it. And then I'm going to open the output file and write the bytes of the file to the new file. And I'm going to call this take an input file, which I'm going to use this twitch.png, and all I want to do is copy this file into a new file, the bytes of this file into a new file. And a file is just a sequence of bytes. I want to take those bytes, grab them from one file, and copy them to a new file without modifying the bytes at all. And this is, in general, what we want to do with homework 3 when we're uploading media files. If somebody's uploading an image when you're testing, check the image that you're uploading, upload it, that goes through all the multi-part stuff. The browser turns it into a multi-part request. Your server parses the multi-part request, extracts the bytes of the file, and then saves those bytes to disk. what you save to disk on your server should be the exact same bytes that you sent when you uploaded that file from the client. So a lot goes on in the middle here, but just to kind of isolate what some of the issues can be, we're going to copy this file, just reading the bytes and writing the bytes. And we get a perfectly good copy. Go us. So what can go wrong here? I have another version of this code. Here I am using with as each time instead of manually closing my files. I'm going to read the file, and I'm going to do the absolute most straightforward bad thing that you can do. Hopefully nobody did it this badly, where I'm very, very explicitly converting the bytes of an image to a string using str. I'm going to convert the bytes. I've read them in as bytes, read those bytes, convert it to a string, and then save those bytes. And one thing I forgot to do, oh my goodness. Run this again, go to Finder, go to twitch.png, get info. You can go to your file system and get the exact bytes of the file. So here's my input file. It's exactly this many bytes. And when I look at my output file, my copy.png here, and I grab the number of bytes for the file, these need to be exactly the same. When we copy a file, we want it to be exactly the same. When you upload a file, go through all the multi-part stuff and save that file, it should be the exact bytes, byte for byte, bit for bit, exactly the same content. We want to make sure nothing gets corrupt along the way. One thing I'll often see is this. You're going to be off by 2 bytes. You have 2 extra bytes in your after all the multi-part stuff because you have that extra /r/n at the end of the bytes of your image. Very, very common mistake. So we want to make sure the bytes are exactly the same. When we switch to copy file bad, we're going to run this thing. We opened it, converted it to a string, and then encoded it again and saved that copy. If we go to this copy, it won't even load. The bytes are completely corrupt because an image is not a string. How many times you've heard me say that? I should just stop saying it at this point. And if I get the bytes of this file, I did not copy it. It's 4,800 bytes now. So we more than doubled the size of the file. Whatever Python's doing with this, like Python can't convert these bytes to a string because it doesn't follow any string encoding. It doesn't follow our UTF-8 encoding, which is the default that string is going to use. Since it can't decode this as UTF-8, it doesn't know what to do, and I don't know what it's going to do. It's something that's wrong. It's not going to give us the same bytes when we encode this or decode this and re-encode it. It's not going to give us the same bytes. It's giving us a completely corrupt version of our file. So we can't convert the bytes of an image to a string. And usually it's not going to be that blatant. You're not going to put the bytes of your image in a string constructor like that. But you might incidentally do something like this. You might try to decode it. Hopefully not directly like this, but you're going to decode it as one of the first lines in your request constructor. You're going to try to decode a request that contains the bytes of a file. That's the actual danger of homework 3. But effectively, it'll be this. Let's run it. And we see the error that a lot of you, well, those of you who have started, not many of you even started homework 3, but those of you who have made a few submissions, a lot of you have seen this error. UTF-8 codec can't decode byte at position 0. It's usually position 0 because it's the very first one. Or actually, I take that back. If it's in the request, it won't be. But right from the first byte of this image, the first byte was 8-9. That's going to start with a 1 and then a 0. If it's 1, 0, 0, 0, 1, 0, 0, 1, right? That should be the first byte if it's 8-9. That does not follow any of the structure of a UTF-8 string. A UTF-8 string starts with the first byte is the number of ones that matches the number of bytes of that image, and then continuation bytes are 1, 0. This one starts at 1, 0, but it's not a continuation byte. Can't decode it, breaks. And this time it actually gave us an error and crashed the server. And this is what a lot of y'all see in homework 1. This is the error in in Autolab, now that we have our error messages back, this is the error you'll see. Something similar to this. The byte will be different, the position will be different, but the rest of it will be the same. That's when you're decoding an image, bytes of an image as a string, which I've seen said so many times. That's what you're doing if you're seeing this one. But when it was a string, you're getting the same error here, kind of. The same thing is happening, but this happens silently. This is much more scary. This is more dangerous because you corrupted the image, you got the wrong bytes, but Python didn't say anything about it. It just silently did its thing. So at least with .decode, you get the error message. Also, if you're submitting like that, I know you don't have test cases, so there's that too. And then if we don't have this B here, and we tried to read, this is the same thing. We're not reading in binary mode, so we're going to get this error again, because once we try to read the bytes of the file, by default, Open is going to open this file in string mode and assume that it's a text file, and it's not a text file. We go to read the bytes, it applies the UTF-8 codec, and it breaks. Can't happen. Can't read that thing. So we have to be careful with the bytes of the image, and of course our image is still, well, it didn't even get to that point in the latest few runs. So never, ever, ever convert the bytes of our image or any binary file into a string. Hopefully I've said that enough times. But it does get a little more intricate than that, so let's get into another example. Where I want to start with elephant. And I want to do something similar. I'm going to take the bytes of an image and put it into kind of a pseudo HTTP request to show more of what we're going to do in the homework. I'm not going to do multi-part here, but I am going to open the image. I'm going to create kind of a request, but I'm going to put the bytes of the image right as the body of the request. So it's more in line with how you're going to send responses that contain images, where the bytes of the image is the body of your response. But I'm going to put this in the format of a request because that's what we're going to parse, but I'm not going to do all the multi-part stuff. So for your purposes, for the homework, you'd have all the multi-part stuff, but I mean, I'm not going to give away all the solutions to the homework in here, but I will give kind of partial, I guess, solutions. So my request is all the headers, the blank line, and then right to the bytes of my image after that blank line. And I'm going to start with, actually no, I want to start with the bad way of doing things. So I'm going to start with the bad way of doing things. Let's take a look at 3 different approaches. We'll save the good one for next. Worst will be last. I want to start with the bad way. I'm going to take my request, I'm going to split it on this blank line sequence, and right there, spoilers, this is going to be the issue right here. With this very first line is going to be the issue. And I'm going to print out how many splits I got. Now, we would expect 2 splits if we're splitting on that blank line. We should expect 2 splits, one with the headers and one with the bytes of the image, the way things are structured right here. With multi-part, you're going to get more parts because there's more blank lines in the parts themselves. But for our purposes, we're expecting 2 splits. So the first one is my headers. The second one is going to be, this we were doing in the other lecture. The second one should be just the bytes of my image in this case, because the image is just the bytes of the body. It's only the image. There's no multi-part anything going on with that. I'm printing the headers, but I really don't need to. And then I'm taking the bytes of the image. No, actually, I don't want to print them out. We're taking the bytes of the image and writing them to output.jpg. Just writing them in binary mode, so we're doing the binary stuff the way we expect. Then I'm going to print the number of bytes that were saved. And I forgot to mention, but when we're opening the file, I'm going to print the number of bytes that were read from the file as well. Now, if everything goes perfect, these numbers should be exactly the same. I should read the exact number of bytes that I write, and then I'll kind of assume that those are the right bytes. I would have more testing to make sure that they're the exact right bytes, but that should get us in the ballpark at least, if we have the right number of bytes. So let's run this. And we get 68,578, 68,578. So it's a bad example, but we got away with it. So we ran this code. Let's not even read the headers. Who cares about the headers? We're interested in the image. So we split on that sequence. We extracted the bytes of our image, and everything worked just fine with the elephant. So let's switch this to a new image. I'm going to do goose.jpg, which is, oh my goodness, where am I? Right here. Goose is this image, which is a little bit busted up already because I played around with this image too much and kind of broke it somewhere along the way. But we're going to have this cute little cat with a clear label, and the bottom half looks a little bit different than the top half here. So we should get this image. So let's run this again. And right here. Goose is actually Lana's cat. We got this image from Lana. So we only got half a goose. Poor goose, yes. And if we look at the number of bytes, we started with 8 megabytes of image details, and we ended up with 194K. So what happened here, we lost a lot of bytes. We lost a lot of this image. So the issue with this is that we're splitting on /r/n/r/n, but those bytes can appear in the image. And there is, for LO1, there's a test case where I have an image that has these bytes in it. And if you're splitting on /r/n/r/n, those bytes can just appear in the image. So if we take /r/n in binary and print it out, it's these 2 bytes. Because you might think, why the hell would a new line character, a carriage return and a new line, why would that ever be inside an image? It doesn't make sense. It's not text. Why does it have a new line character? Which is a valid thought, a very reasonable thing to wonder. And the reason is that these bytes are not /r/n. These bytes are just 2 bytes. They're just 2 bytes. It's 2 sequences of 8 bits. And then ASCII, the ASCII encoding decided that if you are an ASCII string and you want to represent these characters, use these bytes. It's a very ASCII specific thing, a UTF-8 specific thing. It's specific to those character encodings where they decided that for their encodings, these 2 bytes have these 2 meanings of a /r/n. JPEG has a completely different encoding. If we have a JPEG image, we're not going to go tell JPEG that they can't use these 2 bytes. They're going to say, if you have an image, you can't have these 2 bytes next to each other. That's insane. You can't do that. That represents /r/n in my other encoding over here. No, they're just 2 bytes. They're 2 of the 255 or 256 byte sequences, bytes that we have available to us. We're not going to restrict and say you can't have those 2 specific bytes next to each other. It's just going to happen sometimes. And I'm scrolling down on the wrong thing. And specifically, it's ODOA. That's what these 2 bytes are. O, the first 4 bits is a hex 0, and then a hex D, and then a hex 0 and a hex A. So 0D, 0A, these 2 bytes next to each other, that is a /r/n in UTF-8 and ASCII, but that can just appear in an image. So if we have 2 of these back to back, 2 of these byte sequences, we have 0D, 0A, 0D, 0A, anywhere in our image, which is a perfectly valid sequence of bytes to have. If that occurs anywhere in our image, then we're sunk. We can't split on that byte sequence because that byte sequence might just appear in our image. And that's allowed, especially if it's like an MP4. We have a very large MP4. The odds go up that we're going to have just some random sequence of 4 bytes occurring in that image, and the goose image does happen to have this sequence in its bytes. We can look through its bytes and find that this sequence is in there, is in that image. So we have to be careful of that when we're splitting on, when we're splitting like this. We can't do this. What we need to do is split on the first occurrence of this. Now, for a lot of you, you'll take the easiest answer and just hit it with a (1). Give this a second argument, and that's going to split on only the first that many occurrences. If you give it a (1), it's going to only split on the, oh my goodness, I thought this was going to be quicker. The max split, oh my God, well, that didn't work for me. The max splits of 1, then that's going to only look for the first instance of that sequence and then give you exactly 2 splits. What's the /x in the beginning? That just means that it's hex formatted. So it's saying, where was that? So it's saying the next 2 characters are going to represent a hex byte. Okay, so let's look at the good way to do this. Here, you can take the easy way out like I just showed. Let me re-break that because I don't want to, the next time I use this in lecture, use the bad example and have it work perfectly fine. But you can take the easy way out. I'm fine with that. But that's not always going to do what you want it to do. Sometimes you're going to need a little more flexibility. You're not just going to want to split on the first X occurrences of some substring or subsequence. So for full power, I like to do it more manually. We're going to build this delimiter as bytes. We can't do anything in the world of strings. We have to be in the world of bytes. So in the world of bytes, I'm going to create this as a byte sequence. Find, which will give me the index of the first occurrence of that sequence in this byte sequence. And it's going to give me the index of the first byte of it. Because I have a 4-byte sequence, it's going to give me the index of the first /r of the first occurrence of that sequence. So I have that index, and I'm going to use my Python string. You can use it for strings too, but my list splicing syntax here, which is going to give me a sub-list of this list. The colon specifies a range. So I want to say, say, from index 0 to this index. That's going to give me this range of indices with the first one inclusive and the second one exclusive. So it's going to exclude that endpoint. That endpoint is referring to the first /r of this sequence, which I do want to exclude, so I don't have to do any -1 here. I'm going to go from 0 to the first byte before the first occurrence of this, which is exactly my headers. That's exactly what I want in this case. If you leave off this 0 and just do :index, Python will assume you want to go from the beginning of the list, and you don't have to do that 0. So that's going to give me all the headers. That's everything before the delimiter. And then I want to splice and get everything after the delimiter as well. So that's the index, which is this value right here. I'm going to add the length of the delimiter. That way, if I ever want to change the length of my delimiter, I don't have to change that in 2 spots. So I'm going to dynamically get the length of my delimiter, which will be 4 in this case. So start with this index plus 4. So 1, 2, 3, 4 is the first byte after the delimiter, which is exactly what I want, inclusive of the first index. So it's going to start at the first byte of my image. And then just like we said, colon with nothing before it, start at the beginning. If I do colon with nothing after, that's going to go until the end of the list. So instead of doing length -1, I can just do a colon and leave it at that, and Python will know what I mean by that. It means start at this index and go all the way to the end of the array. Get everything else. And those should be exactly the bytes of my image in this case. For doing multi-part, you'll have extra steps there. You'll encode the boundaries in bytes. Look for those. Look for the indices of the boundaries. Add your extra dashes and stuff like that. Do all that good stuff. For our purposes, we're just going to get the image directly. For multi-part, this would be the entire body, and then we'd have to look for boundaries and go through all that. And then for each boundary, start this process over, look for this delimiter again as well. And then once I have the bytes, I'm going to open my output file, write to it. It'd help if I called this method. And I have the exact bytes that I'm looking for here. And my output should be the original partially corrupted image. So that's the best way to do things. And this is where I think most of you have or will have. Most of you didn't start homework 3 yet, but which is crazy to me, but you know what? I'm not going to fight that battle. Where you'll actually get this issue is in your request constructor. Like the first thing you do for multi-part parsing is you'll call your request constructor so your method can get a request object. Actually, now that I think about it, that's happening in my code. I'm calling your request constructor. Is that right? Yeah, I'm calling your request constructor, getting the request object, and then giving it to your code. Maybe that's where some of the confusion is coming from. And in that constructor, you're going to do .decode. I'll re-encode it just because my code works on bytes, but somewhere in your request constructor, you're probably doing this on the entire request, which is acceptable. Like that's what I would expect you to do in homework 1 when you wrote that code. But now that we're worrying about bytes, we do have to correct this one and fix this, update that constructor or whatever helper method your constructor is calling to not treat the entire request as a string, because this is going to break things. No matter what we did, we're going to get this error because now our request contains the bytes of an image, and we can't decode that request until we parse out the bytes of the image. Now, once we have the headers parsed, we can do headers.decode. That's fine. So we want to make sure we extract the bytes that we know are going to be strings. We know the headers are going to be a string. Then we can decode and do all our string parsing code. So we're still using all that string parsing code. Your header parsing code to get that dictionary of headers, that probably should work as strings. I mean, mine works as strings. But I'm going to make sure I extract the headers by looking for the first occurrence of this sequence. And then everything before that, I can safely decode as UTF-8, because headers are ASCII only, which is a subset of UTF-8. So I can safely parse that as a string because it cannot contain any non-string data. But anything in the body of the request can contain images, videos, whatever. So we can't just convert that to a string because we're going to get this error right away. We're going to get the codec error immediately, and then the program crashes. There's nothing we can do from that. We can't recover from that. So we have to be careful about that. And then the worst one. Let me change the code first so I don't forget. This is the worst one, which some of you might be doing this. For homework 1, this isn't that bad of a thing to do, but homework 3, we got to tighten up things and be aware of a lot of this, is instead of splitting on /r/n/r/n, you're going to say, well, I got all these headers to parse. I'm just going to split on new lines. I'm just going to split the whole request, the entire request on new lines, and then I'm going to go through my lines and parse that. Well, I'm going to grab the first one. That's my request line. Then I'm going to go loop through these things. Those are all my headers until I reach a split that's the empty string. And once I reach that one, I know the rest is my body. So whatever the next index is, that's my body, and done deal. Well, now it's not, okay, if my image has /r/n/r/n, now it's, does my image have /r/n, which the probability of that hitting goes significantly up. Where am I printing the headers? I'm blind. Right here. So now I lost way more bytes to Goose. Goose is all but gone, sadly. And now, even when I go back to my elephant with this absolutely horrible way of doing things, I'm losing some bytes to my elephant as well. If I look at my elephant, he's missing his feet. He's not doing so good either. So we want to be very careful how we're splitting. Don't just split on some sequence. Make sure you're looking for the first however many occurrences. Just be careful how you're splitting these things. If there's nothing in the protocol that says this thing has special meaning or whatever, like, for example, the value of a header can't have a new line character in it. You can't have a line break in the middle of a header. So once you have your headers extracted, yeah, split on /r/n. Absolutely. But you can't split the entire request on that because you don't even know what the body looks like at all. You don't know what type of information is even in there until you start parsing headers. or at least the request line to figure out what the path and method are, you have no idea what's in the body yet. So you can't make any assumptions about what's in there. And then there are some assumptions we can make later, not assumptions, but like the boundary has that guarantee that the boundary cannot occur in the content. So no matter what your file is that you're uploading, the boundary will not occur in that data. So we do have that guarantee, so we can split on boundary all day. But anything else, these /r/ns, especially, like these 2 bytes, that sequence of 16 bits might occur all over the place. It's in this elephant image, for example. So elephant, I don't think I modified elephant at all. I think that just naturally had /r/n. So your elephant that you have should have that /r/n in there. So you can use that for testing. Okay. Any questions on any of that? Okay, good. So we got to this part earlier than the other lecture, which is good because I ran out of time, kind of caught me off guard. I want to get to a certain point in this example. Again, unless there are questions, I'm happy to pivot. Okay, so now let's get a multi-part test case. Close other. What I want to do is build a test case for my multi-part parser. That's my ultimate goal here. So let's get a test case. The first step for this is getting the input for the test case. That's mostly what I'll talk about here, is how do we get a valid input to test this thing, especially an input that contains an image. How are we going to do that? Well, I'm going to run my server. Oh, I did delete it. I'm going to run my server, and then go to my server. I'm going to upload an image. I'm going to stick with this elephant small image. I'm pretty sure I put that in the handout code. Hopefully I did. I meant to if I didn't. This elephant small, it's the smallest image, so I can have some reasonably-ish sized test case. Ship it. And I expect an error here because I deleted a bunch of my code for the example. So I stopped leaking solutions. But what I got here when I posted that is just the headers. So I can try to use this as my test case. It's partly a test case, but not the whole thing. Because the way Chromium browsers send images is most of the time, but not always, it'll send just the headers like we see here. Then there's a short delay, and then it'll send the bytes of the image and the whole body of the response. The problem with this is if we're trying to get a test case, we don't have a test case. One simple solution to this is use Firefox. Oh, I don't want to open Firefox. It takes forever. I shouldn't have clicked it. Sure, that didn't take too long. One solution to this is do Firefox with elephant small. Firefox will start sending the bytes right away, so I have my full test case right here. So that's probably the easiest. Use the elephant small image in Firefox. I guess that is the easiest answer. There's your test case. If you're not using Firefox for whatever reason, you're like, I ain't doing that. What we can do so I'm parsing my request. So even if I only have the headers, that first parsing is going to go fine. My request constructor is making sure it's not treating the body of the request as a string. So even when I got the whole request, I'm not, nothing's breaking there. So I can call my constructor to do a lot of the parsing for me. And then I want to do this is where your buffering code would go, and this is kind of half of the answer, to be honest, is request. I turn off my autocomplete, so I got to think of this. Headers dot get content length. Not a string. I want that as an int. It's a header, so all the headers are going to be strings by default. Content length I expect to be an int, so I can safely convert it to an int. If my content length is greater than the length of request.body, guess what I got to do? I got more bytes to read. I didn't get the whole request. So I know that I have to keep reading more and more bytes from this. And for my purposes here, I'm just going to print to the screen. I'm going to print this. I'm going to cut and paste it too. I'm going to read from the socket again and just print the new bytes to the screen. Because my goal here is just to get a test case. So let's rerun this. Let's make sure that reran. Now, even with a Chromium browser, bless you, I have the bytes of my image. I have the entire body. I can tell it's the entire body because I can see my boundary here with a trailing dash dash. That's our way of indicating the end of the multi-part request. So I'm going to grab this. That's the body. Go to where my test case is going to go. Paste it. Go back to my, oops, I don't have to do that. I can just go right here. Go back to my requests. I'm going to look for media uploads. These are the headers to that request. So I'm going to grab this guy, paste it, and then smash these together. So I'm going to be very careful, surgically do this. I want to get rid of the B apostrophe and then the closing apostrophe there, or quote, not apostrophe. Well, I guess it's the same thing, isn't it? And combine that into one request. So here's the bytes of my request. And we can format this a little better using multiple lines if we want. I'm not going to do a lot of it here because it takes up too much lecture time. But I do want to get to my boundary. Then you're going to put this in call this request, I'm done with this, request bytes, request, let's call it request, equals request, slam this in my constructor, parse multipart of request, I don't know, parsed. And then I can start asserting. Assert, request parsed, dot boundary should equal this boundary that I expect. And based on the spec, that should be a string. So make sure you have the right types. It should be a string, not bytes at that point. Assert request parsed dot parts oh my goodness equals 1. I only have one part to this request. Then I can start asserting everything about this. If it's already asserted that there's 1, I can do parts of 0. Actually, let's do that. Assert the big one here. Let's do the big one. Assert, I already asserted that there's only one part, so I can safely do parts of 0 equals in binary. Now I go to my actual thing and very carefully again. So in the part, I'm going to have this blank line character, and then after that blank line, this is the first byte of my image, and I can see my signature here. If you're thinking AO1, you can see the signature. It's a JPEG, so better have the JPEG signature. And then go all the way to the end here. My boundary, make sure that I exclude that trailing /r/n. Right after the bytes of my image, there's going to be /r/n -- then the boundary, -- and then an optional whatever after that. It's up to the browser. The spec says whatever comes after this trailing dash dash, it's not part of the protocol anymore, and browsers are welcome to do whatever the hell they want. So this might be here, it might not. There might be some note that says, hi, welcome from Chrome. They can put anything they want there. Anything after the last boundary, your code should ignore. But I want to grab exactly the bytes of the image. And that's exactly what I should have as, I got to remember what I called it, content maybe? There's no way I got all of that exactly right, is there? Oh, yeah, I did. Okay. Well, I don't get to talk about more stuff because I thought at least I got the name of this variable wrong. So my test case passes, so I don't have anything else to say about that. But this is how you can write a test case for your thing. Let's say, for the sake of argument, maybe my test case is broken. Because I can't go into my code because I'm showing solutions. But if my test case is broken and something fails here, once it fails, first of all, good test case. I didn't test everything. I should check the headers of the part and everything else. But if something fails, if you've taken 116 with me, you know this one, run the damn debugger. So run the debugger, and I'm going to look at my parsed request parsed, and look at what's in here. The boundary, if that's what's failing, I'm going to look at this boundary, and start comparing what's exactly different. And if I have to, I'm going to start stepping through my parsing code to figure out exactly why there is a discrepancy. I'm going to look at my parts, content headers, make sure everything's here the way I expect it to, name of upload, make sure everything's there. If anything's missing, I'm going to start stepping through my code step by step. Strongly encourage you to use the debuggers. I feel like I harp on it really a lot in 1.16, but hardly anybody uses it. I kind of get people to use it in 1.16. Then by the time I see you again in 3.12, it seems like everybody forgets what the debugger is. Everyone wants to use VS Code and then doesn't set up the debugger for VS Code or know how to use it. And it's just frustrating in office hours. So in office hours, I'm going to start stressing the debugger a bit more because it can save you hours and hours and hours of time. A lot of you are spending way more time than you need to on these homework assignments. They're not that hard for a 300-level student. You should be ripping through these things way faster than you are. Use the tools available. Write your tests. Use the debugger. Do all the things that we've shown you to do. Some of y'all have trouble writing classes. That was like early 1.16 content. I know it's different in Python, but not that different. It should take you like half an hour to study the differences. How does a constructor work? Where do the instance variables go? It doesn't take that long. So there's that, and then let's do, that's a multi-part request with just one part. There are other things we want to do. Where am I? Public. But some of my test cases have quite a few parts to them. So let's go to our, oh my goodness, where is it? Somewhere in here. Go to our form. I'm going to get rid of the upload entirely. And have a request with 4 different parts. I don't have to refresh the thing, I just have to refresh the page here. Are you sure? Why isn't it working? It's probably because I'm stuck in an infinite loop somewhere. That shouldn't break it though. Oh, come on, what did I do? Oh, yeah. Yep, that's fair. Oops, wrong thing. Yep, that's fair. Actually, I didn't read that. I kind of assumed. If I get a request without a content length header, that line's going to break. Actually, that shouldn't get a request without, yeah, whatever. I'm not worried about it. Not worrying about it right now. Okay, so let's send this request. And now this one's quite a bit more straightforward than the image one. I'm going to get the whole thing in one request because it's not going to overflow my buffer. There's no file to read from disk, so even Chromium's just going to send the whole thing right away. It's all just text. So a lot more straightforward to get the test case. And then I can go to my multi-part. Oh, I put everything in main. Another main. Oh, what am I doing? My brain's already on break. It started a few minutes early. Def. Request bytes equals this whole thing. And then I know exactly what to expect from each part in each order. I can, let's do it. Let's do this. Since the order of the parts is specified, like in the homework doc, I can say, let's just do one to make sure. Oh my goodness. It was comment 3, 4, 5, because that makes sense. So 5 is the fourth one at index 3. I made that one really easy on myself. So request parsed dot parts of 3 dot content should equal this in bytes. And hopefully this one passes. Assert. This one might not. I feel like I made some mistake in there somewhere. Main, another main. But my point for all this is you do want a test case that has multiple parts. That is part of the parsing multi-part, but my first example only had one part. But making sure you can parse files and multiple parts, make sure everything works, nice and robust code. You can do that by testing, debugging, all that good stuff we talk all the time about. Any questions on any of this? Debugger, but I don't know where. Yeah, then don't use VS Code. I get you want to use VS Code. There's downsides to using PyCharm, which I recommend for the course. It's downsides to using it, mostly that it takes up like every resource in your device and slows everything to a crawl. But it does have a lot of really good tools that makes your life easier. So if you want to use VS Code, fine, but I mean, you're hampering yourself if you're just throwing away the utility of a debugger. It can save you hours and hours of time. I couldn't imagine coding without a debugger these days. I would waste half my life just debugging without a debugger. And of course, right before break, my music doesn't want to start. Not like this. Don't go out like this. So it called it like right 0.1 seconds late. But my code called the play method, but I'm not getting a response. So either the Wi-Fi is crapping out or Spotify is crapping out. I promise my code's good.